This is Physics 1. In this video I'm going to solve the following problem. A car which stands still starts to accelerate on a circle with radius of 100 meters. The coefficient of static friction is 0.6 and for kinetic friction is 0.4. What is the maximum speed the car can have? What is the largest tangential acceleration the car can get? So here is the surface of the earth, x and y. This is the car. It's moving on a circle on the ground, so it's all the ground, and the velocity is v, and we are interested in finding the maximum speed. I'm going to use Newton's second law, F, in vector format equals ma, and in the radial direction I will get m v square divided by r. So v is basically the tangential speed which is asked, and r is the radius, is equal to the radial force. So let's say F r, and it has to be toward the center, so Fr is in this direction. So the only force that is in radial direction is the friction. So now I have x and y. Let's do another figure, z. So this is now toward the sky, and let's say here is the surface of the ground, here is the car, it's moving in this direction. So now the car is being pulled down by gravitational force mg, and the surface is pushing it up with normal force. Since the car doesn't move in z direction, it has to be equal to mg. And now the friction force, we usually show it with F mu, is equal to mu, which is the coefficient of friction. The car is actually, so we have to use a static friction. I will let you know why we have to use the static, although the car is moving. And it's mu times n, which is the normal force. That's the maximum friction force that can be applied. So it's equal to mu mg. So let's put that equal to mu mg, and then now I can cancel the m. So v is square root of, because I have v square, the square root of r times mu times g, r mu g, which is 100 meters times 0.6, which is the static friction, times 9.8, and these are all in SI unit, so therefore the velocity will be in SI unit as well. So this is equal to 20.2 meters per second. So this is the maximum velocity that the car can go to stay on the circle. Now if the car moves faster than that, it can't stay on the circle, it will slip out. Now the reason I said we have to use static friction instead of kinetic friction is that it's the tire of the car that is always at rest when it is on the ground. Otherwise the car slips. So if we assume that the car is not slipping, that means the tire at each moment is at rest on the ground. So since it's at rest, we have to use a static friction. If the car was slipping, then we had to use kinetic friction. Now let's see what is the largest tangential acceleration the car can get. So it's basically tangential acceleration. So we know that the car is applying a force to the surface of the ground, and then the ground applies a friction force to the tire, which is again a static friction in this direction. So therefore we have also another frictional force in that direction that is pulling or pushing the car forward. So now the maximum that also can go or that can be is F mu again. So F mu equals mg mu static, it was static as well, equals m, so this is Newton's second law, m a tangent. So now a tangent maximum is g mu s again, which is 9.8 times 0.6 in SI units. So therefore, let's say SI units. So therefore, this is almost 10. So it's almost 6 meters per second square. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.